Awesome. So now we've got some other forces.
Normal.
Yep, normal force. Any idea what that one's going to be equal to?
Yes.
I can tell that you know.
Well, I had a couple different thoughts, but isn't it just like countering the gravity?
Yeah, the y-axis of gravity.
Yeah.
So
it's just going to be whatever that is, but opposites.
Good. Yeah, so we have to be careful because sometimes we're tempted to say, oh, normal force is always mg. Because on flat ground, if we have a box sitting on level ground, gravity goes down, normal force goes up, they're the same. In this case, it's similar, but it's not going to be equal to all of gravity. It's just going to be equal to the amount of gravity that's in the y-axis.
Okay.
So it's going to be equal to this 260 newtons.
Mm-hmm.
So normal force equals 260 newtons. And the reason for that is because if one of these was bigger than the other, that means we would have a net force. If we have a net force, that means we'd have acceleration. So we'd either be accelerating into the ramp, which that would be weird if it just started burrowing itself into the surface of the ramp, or off of the ramp, which we know that when we see things slide down ramps, they don't just randomly, pop off. So we know that these things need to equal each other out, and then that way we have, they stay together the whole time. There's no acceleration in or out.
And then up.
Yep, so now we've got a pushing force.
Pull, yeah.
Or a pulling force, yeah, if we're using a rope or if we're pushing. And that's going to be equal to, any ideas? It'll be equal to the x component of gravity, since we're traveling at constant velocity.
Yeah, I see. Yeah.
So I drew this arrow kind of long, but we would want it to be equal to that guy.
Yeah.
So numerically, it would be 150 newtons. And the reason for that is because since this box is traveling with constant velocity, that means there needs to be no net forces. Everything needs to cancel out to zero. Because if there are net forces, that means there's acceleration. And we're not looking for an acceleration situation.
So do you even need to know the velocity?
Yeah, so don't need to know that.
It's just the fact that it's constant.
Mm-hmm. It could be traveling at 1,000,000 meters per second, and the free body diagram would still look
So
exactly
those are all
the
the
same.
individual ones, but altogether it's just going to be zero is the answer of total.
Right.
Like calculating all the forces.
Yeah, because we know that net force equals mass times acceleration. If there's no acceleration, constant velocity, then we need to make this equal zero. So all the vectors need to cancel. So we already saw that there, and now we see that here, so we're good. So then if we were going to say, well, how much work are we doing if we're pulling this box 10 meters or something? We would say, well, work equals force times distance times cosine theta. So the force that we're exerting as we pull is that 150 newtons.
The distance is whatever we make up, so like 10 meters.
Yep.
And then cosine of 30, which is the angle.
It wouldn't be 30. It would actually be 180. Let's see if that comes out. 180 cosine. Yeah. You could either call it 180 or 0 because... So really, the way I like to think about it, this is the way your textbook says it. The way I like to think about it is work equals whatever force is parallel to the distance that it's, to the direction of the distance. So in this case, it's moving this way. Since our pulling force is also that way.
When would they not?
If you had a box, let's say I have a box and I have a rope, and I'm pulling it at an angle.
Even though the ground's not going up?
Yeah, so what's actually going on here, since I'm pulling it like that.
Oh, so you're just saying he's pulling it flat to the surface,
Mm-hmm.
but it's on a ramp. And this one, it would be like flat, but you're pulling it. Okay. No,
Right.
difference.
Yeah, so in this case, this would be split up into vectors like that and like that. So I would just, whatever this vector ends up being, I would times that by my distance, because that's the one that's parallel to the movement. So in this case, it's all parallel to the movement, so it's just 150 times 10. And that would come out to be in joules as well.
Awesome.
Make sense?
Yes.
Cool. Hopefully that was helpful.
Awesome.
Awesome.